Welcome back to the Cat Handler lecture series. जय बजरंगबली, जय हनुमान जी, जय सीताराम, Om Namah Shivaya. Now the important points regarding, we talk about the important points regarding a spring constant, that is composite spring pendulum. When a spring of a spring constant K is cut into two pieces of length L1 and L2, then the spring constant for both length, that is for the length L1, is given by K1 equals to K into under bracket 1 plus L2 by L1. And similarly for a spring constant of length 2 is represented by K2 equals to K into under bracket 1 plus L1 by L2. Now let's discuss about the simple pendulum. Some important points regarding simple pendulum. The time period of a simple pendulum is given by T equals to 2 pi into under root L by G, where L is the length of pendulum and G is the acceleration due to gravity. The period of a simple pendulum depends on length as T proportional to under root L. So the graph between T and L will be a parabola, while between T square and L will be a straight line. Time period of a simple pendulum is independent of mass, shape and material of bob, and it is also independent of the amplitude of oscillation, provided it is small. The time period of a simple pendulum depends on acceleration due to gravity as T proportional to 1 by under root G. So with increase in G, time period will decrease and vice versa. Now if the length of a simple pendulum is comparable with the radius of Earth, then time period T is given by T equals to 2 pi under root 1 by G into in the bracket 1 by L plus 1 by Re, where L is the length of simple pendulum and Re is the radius of the earth. Now the cases arises is if length of pendulum is very greater than radius of earth, then T equals to 2 pi into under root Re by G equals to 2 pi under root 6.4 into 10 to the power 6 by 9.81 equals to 84.6 minutes. And if length equals to radius of earth, then T equals to 2 pi under root Re by 2G equals to 2 pi under root 6.4 into 10 to the power 6 by 2 into 9.81 equivalent to 60 minutes. If a simple pendulum is suspended in a lift and lift is accelerating downward with an acceleration A, then its time period is given by T equals to 2 pi into under root L by G minus A. Similarly, if a simple pendulum is suspended in a lift and lift is accelerating upward with an acceleration A, then its time period is given by T equals to 2 pi under root L by G plus A. The simple pendulum having time period of 2 seconds is called second pendulum. If a simple pendulum is suspended in a lift and the lift is moving upward or downward with a constant velocity v, then its time period is given by t equals to 2 pi root under 2 pi into under root L by g. If a simple pendulum is suspended in a lift and lift is freely falling with acceleration g, then its time period is given by t equals to 2 pi into under root L by g minus g equals to infinity. If a simple pendulum is suspended in a carriage which is accelerating horizontally with an acceleration a, then its time period is given by t equals to 2 pi into under root L by in the bracket under root g square plus a square. And if a simple pendulum is suspended from the roof of a trolley which is moving down an inclined plane of inclination theta, then the time period is given by t equals to 2 pi under root 2 pi into under root L by g cos theta. Similarly, if a simple pendulum whose bob is of density rho oscillate in a non-viscous liquid of density sigma, where sigma is less than rho, then its time period is given by t equals to 2 pi into under root L by in bracket 1 minus sigma by rho into g. If the simple pendulum has charge q and is oscillating in an uniform electric field E, now electric field is opposite